Now, the dermis of the skin is very, very important. Okay, so we've already learned about how the epidermis helps make us waterproof and does all those kinds of things and how it does that using its tissues. Well, the tissues in the dermis need to do something very, very different. Now, we know that the epidermis has those epidermal ridges or those dermal ridges that are going to interlace with the dermis. Now, the dermis has two primary layers. We have the papillary layer, which is in that sort of finger-like region where the epidermal ridges and the papillary ridges can kind of mesh together, very much like if you say took two egg crates and kind of stuck them together, um, or even just like interlace several sheets of paper with one another. It's going to get us lots and lots and lots of surface areas so that we can have lots and lots of strength between these two areas. Okay. Now, the other layer of the dermis is going to be made up or called the reticular layer because it's going to contain lots of reticular connective tissue, but it's also going to contain lots of irregular connective tissue, okay? Um, or dense irregular connective tissue, okay? This is basically there to help tie all of the little underlying structures in the dermis in place so that they're not moving around. Then we can then take all of that and tie it to the hypodermis. So all of the structures in the skin are going to need or can stay in place. Now, to help it do that, we need to make sure that it is made up of connective tissue proper. Okay. So that means we need actual areolar connective tissue in the papillary region. We need actual dense, irregular connective tissue in the dermis, as well as some reticular tissue in the dermis, helping hold everything in place. Okay. Now, we're also going to find lots of other structures, those things that we need to hold in place. This is where we're going to have blood vessels, sweat glands, sebaceous glands, all of that kind of stuff, just to make sure that we can, one, supply all of the nutrients and everything that the epidermis is going to need to be able to survive, but two, so that we can also provide all of the other functions that the skin is trying to do. Okay. Now, papillary layer, this is going to be the most superficial layer. Like I said, this is the layer that is up right next to the epidermis. Now, because of this, it needs to be strong, it needs to be stretchy. Why? Because we're putting a lot of friction sometimes on the epidermis of our skin. Imagine if you're wearing a pair of shoes or something like that. Every time you take a step, there's a little bit of friction between your foot and the sock and the shoe. Okay. Now, if you're not wearing socks and your shoes don't fit right, all of a sudden that rubbing is going to rub and rub and rub and rub, and you eventually rub a blister. Now, what you've done when you've created a blister is you've actually separated the epidermis from the dermis. Okay. You've actually eventually worn through the strength that our areolar connective tissue and stuff like that is able to provide. Okay. Now, we have these finger-like projections so that we can get lots and lots of surface area so that we can generate that much more strength. Now, if you remember what areolar connective tissue looked like, remember it's made up of these bands of uh, oh my goodness, I'm having a brain fart. Hold on. Where we have lots of elastic tissue, but we also have lots of collagen. Now, it is this collagen that is going to help kind of give our skin that kind of plumpness and richness, but also that collagen is going to give it a lot of strength, while the elastin is going to give it a lot of stretch. So the collagen kind of gives it its strength and its shape. That's why people get collagen injections and stuff like that, is so that they can puff up their skin a little bit more, so that maintains that sort of appearance of youthful skin, which is nice and full in large part because of the larger amount of collagen that we're going to find, particularly in the areolar connective tissue and finally the reticular layers with all of its collagen as well. So we get a lot of that strength and a lot of that structure there. Now, the reticular layer is the deeper portion, is also going to be the major portion. This is where we're going to find the vast majority of all of the other structures, other than maybe some blood vessels. This is where we're also going to get a lot of strength. Okay. So here we have the epidermal ridges, and those mesh with the dermal papillae. Then we've got all of the reticular layer down here, where we're going to have all of the other structures that we're going to find. So we can see hairs, we can see sweat glands, we can see sebaceous glands, we can see lots of different nerve endings. We can see some nerve endings up here in the dermal region, or sorry, the papillary region as well. We can also see some blood vessels up here in the papillary region too. Now, deep to that, we're also going to see other blood vessels further away from the surface of the skin. Why are they further away from the surface of the skin? Well, what happens to the surface of our skin? Sometimes we get cut. Now, if you get cut very, very shallowly, you may just actually not even make it to uh, the blood vessels in the upper portion of the epidermis, the blood vessels that are supplying the epidermis with all the nutrients it needs. However, further down, we have bigger blood vessels. You get cut deeper, you're going to bleed more. Okay. And that's because you can get to larger blood vessels. Now, deep to this, we're also going to see the subcutaneous layer, which we'll talk about in another video. Okay. Now, also found in the dermis, because we have all of these collagen fibers running through here, we're going to find some of them in these little parallel bundles. And this is going to be parallel in general throughout entire regions of the body. Okay. Now, what this allows us to do is this basically allows us to deal with some of the primary stresses that are going through those areas during particular types of movements, like walking, running, all that kind of stuff. So we're going to have these little tension lines that are going to be parallel to one another. Now, if you get a cut, though, that is parallel to these lines of cleavage, to these lines that are already strengthened in that way, well, they're going to heal quite a bit more quickly, okay? That's because these lines are held in place so that we can maintain some tension in these regions along those lines, just due to their normal movements, okay? So if you have a cut that is parallel to one of those cleavage lines, it is not going to pucker up that much just because it's already parallel to all these lines that are holding it in place anyway. So the cut is going to stay nice and small, and it's going to be able to heal quickly. However, if you go perpendicular to that, okay, so say you go perpendicular to these stretch lines here, well, that's going to cause these stretch lines to pull on that wound. Because the stretch lines pull on that wound, they're going to open it up even more. So it's going to actually keep it from healing as quickly, just because there's going to be this constant strain on that incision, trying to pull it back apart. So it's going to take it a little bit longer to heal. Now, another important part of our dermis and the fact that we have these various connective tissues that we're using to hold it in place, or hold all of these structures in place, whether it's our sweat glands, our nerve endings, hairs, all of those kinds of things, helping make sure they get held in place. This is just a bunch of connective tissue, which remember a whole bunch of fibers running out around, mostly outside of the cells. Okay. Uh, Now, something else to keep in mind here is that this stuff is all trapped. Okay, we are trapped between the layer of hypodermis and we are trapped in but under the epidermis. Now, the epidermis is constantly being abraded, constantly being subject to abrasion and wear. So we're constantly scraping off that outermost layer of cells, okay, and replacing it with new ones. So if you were to say just take a marker and draw on your skin, I was looking to see if I had one. Yeah, here we go. So if we just took a marker and just drew on the skin, well, this is just going to stain those few cells that are right here at the surface. And they're not going to stay there forever, though. Why? Because these cells are quickly going to be replaced. I could leave it here, and then just over the course of a couple days, it's just going to get abraded off, whether through showers or through putting on and taking off shirts, all of those kinds of things. We're going to get enough abrasion on this area that it will eventually go away. Now, if say we wanted to put a mark on and have it stay there over a long period of time, that means we need to get it underneath the epidermis. So that means we're going to inject it down into the dermis. This is exactly what a tattoo is. A tattoo is going to take those needles and they're going to inject dyes underneath the epidermis of the skin. So they're going to inject it into the dermis, into a bunch of long-lived cells that aren't going to be replaced nearly as often. And really not even into the cells, into the spaces between the cells, which means those areas are not going to be really replaced at all. There's really nowhere for them to go. So that dye is now trapped in that area. So now your dye is going to be permanent. It's going to stay there essentially forever. Okay. All because that dye is now injected into an area that is not going to be readily replaced and readily shed. Okay. Now, pigments are going to be made up of various things, sometimes proteins, sometimes just stuff. Okay, so these are big molecules that are down in there. So if you do need to get a tattoo removed, they can do that. What they do is they basically will take a laser, and that laser is going to be used to actually break apart the molecules and stuff of those pigments. Okay, not typically the easiest thing for you. You do know that it is happening, and I've heard from some people that it actually hurt worse than the tattoo did itself. But that is actually one way of breaking down those pigments to get rid of them. Newer inks actually make themselves a little bit easier to remove, basically because they are different types of compounds that are going to be a little bit more easily broken apart by things like those lasers. So if you have any questions about the dermis, any of the structures they're in, or how it's put together, tissues that are make it up, or anything like that, please just let me know. All right, see you in the next one. Bye.